Okay, today we will start from chapter 2, where it deals about matrix. Under these chapters, we will discuss on definition of a matrix, product of a matrix, and some algebraic properties, transpose of a matrix, elementary row and column operations, rank of a matrix, determinants of a matrix and its properties, inverse of a matrix, system of linear equations, eigenvalues and eigenvector of a matrix within some exercise. This is the concept of a matrix. Now let us proceed on definition of a matrix. We can define a matrix as like this: a rectangular array of numbers. That number may be a real number or a complex number into m horizontal rows and n vertical columns, which is enclosed by a pair of brackets like this, or like this, a pair of brackets which is closed by square bracket or open bracket. Such is called an m by n matrix, and we can read as this m by n matrix. Note we cannot say that this as m times n. It is m by n matrix. In other ways, we can define matrix as follows, or a matrix of order m by n can be defined as like this, or we can denote as like this. Matrix A has like this, which is an interest which is with a11, a12, blah blah, a1n, a blah blah blah, am1, am2, blah blah blah, amn. Then now the number of a matrix, or the number in a matrix, is called interest, or the element of a matrix, or those numbers a11, a12, blah blah, a1n, m1, m2, blah blah, amn. Those are called interest, or the elements of a matrix. For the interest is aij. The first subscript I specifies the row, and the second subscript j specifies the column in which the entry appears. That is, aij is an element of a matrix which is located in i's row and j's columns of a matrix. Okay. Remark: the order of a matrix is a number of rows and columns it has. Therefore, when we say that a matrix is 3 by 4 matrix, we are saying that it has 3 rows and 4 columns. The rows are always mentioned first and the columns are mentioned as second. This means that a 3 by 4 matrix does not have the same order as a 4 by 3 matrix. It must be noted that even though an m by n matrix contains mn elements, the entire matrix should be considered as a single entity and is also called the size of a matrix, or the dimension of a matrix. Now, matrices are denoted by a single capital letters such as A, B, C, and so on. The word this matrix is a singular, and matrices is its plural form. A matrix, as definitions here, a matrix of order 1 by n is called a vector or row matrix, and a matrix of order m by 1 is called column vector or column matrix. Here, matrix of order 1 by n. That means this matrix has row 1 and column n. Therefore, we say that this has a vector or row matrix. And this, the matrix of order m by n is also, this matrix has m row and 1 columns, and this is called column vector or column matrix. For example, this matrix For example, this matrix 1, 2.5 is a particular example of a row matrix, or we can write this as 1, 2.5 is the same as, which is the matrix of as columns, which is as a row. This is not point, the point should be ignored, and this can be written as 1, 2.5. It has this the order of this matrix is what, which is 1 by 2, because the entries are only 1 and 2.5. Therefore, this matrix is an example of row matrix. And this matrix, the other matrix 9, 8, 5 as elements, and this matrix has order what, 1, 2, 3 row, and it has 1 column. Therefore, this matrix has order 3 by 1, and this is a particular example of column matrix. Example: let's A is equals to matrix with entry 1, 3, 4, 5, 7, 2, 8, minus 1, 3. Then this matrix Aij, if Aij are those entries here, so when you have this, the entries is 1, 3, 4, 5, 7, 2, 8, minus 1, 3. These are expressed as or represented by Aij. Now this matrix Aij has order 3 by 3. And A1 for this matrix, that means entry which is found in first row and second column. This is first row and the second column, which is 3. Therefore, A12 is 3. That means the element of A belonging to first row and second columns. A22 is equal to 7 because the entries which is found in second row and the second columns. Second row is this, then find the intersections of this second row and second column. Now second row here, second column, therefore which is 7, therefore A to be 7. That means the element of A belonging to second row and second column. And that's all. I32 is also, which is minus 1 because row 3 and column 2, which is minus 1, and A33 is numbers which is belonging to in third row and third column, which is 3. And we said that this matrix A is 3 by 3 matrix, or matrix of order 3 by 3, or matrix of size 3 by 3, or matrix of dimension of 3. Row 1, list row 1. Now the row 1 matrix for matrix A is, which is all of the first row 1 is, which is 1, 3, 4. Therefore, row 1 of matrix A is, which is 1, 3, 4, and row 2 is, which is 5, 7, 2. Row 3 is item minus 1, 3 are the row vectors, and C1, that means column 1 for matrix A is 1, 5, 8. Column 2 is here, which is 5, 7, minus 1, and the column 3 is, which is 4, 7, 4, 2, 3 are column vectors. Another example says that let matrix B is given as 2, 3, 5, 1, minus 1, 0. Then the order of matrix B is, which is 2 by 3. Why? The number of rows of this matrix B is, which is 1, 2 rows, and the number of columns, that means 1, 2, 3. Therefore, matrix B is 2 by 3. And rows of matrix, or the first row for matrix B is 2, 3, 5, and row 2 for this matrix 1, minus 1, 0. This, and the columns of, or the first column for matrix B, which is 2, 1, no 2, sorry, this is 2, 1, to mean that 2, 1, and column 2 is 3, minus 1, and the column 3 is 5, 0. Another example. Now another example, it says that let matrix A is given as 1, 5, 7. It's an example of 3 by 1 column matrix, and 3 minus 9, 1. There's no here comma. 3 minus 9, 3 is an example of 1 by 3 matrix of row matrix. And another example, which it deals about submatrix. What means submatrix? Submatrix of a matrix is any array or arrangement which is formed by deleting one or more rows or columns of A. Now, the definitions also allows us the deletion of a combination of rows or columns. For example, matrix A, if let A is matrices, which is with the entries 1, 3, 5, 2, minus 1, 4, 4, 9, 0. Then, if we delete second row of A, if we delete second row, that means if we delete this 2, minus 1, 4, then we obtain, or the sum matrix will be what? 1, 3, 5, 4, 9, 0, or we obtain a matrix of order 2 by 3. Another example, if we delete for second matrix, if we delete the third column of matrix A, the sum matrix will be like this: 1, 3, 2, minus 1, 4, 9. Well, that means we obtain 3 by 2 sum matrix. And if you delete the first row and the third column of matrix, the sum matrix will be in such a way: 2 minus 1, 4, 9 of order 2 by 2. Other definitions are that 2 matrix A with entries Aij of order m by n and the matrix B with entries Bij of order m by n are said to be equal, and we can write as A is equals to B if they are the same order, or if they have the same order, and if all corresponding entries are equal. In other words, or we can simplify as 2 matrix A and B are said to be equal matrix if their corresponding, or if their size, or if they have the same order, and if their corresponding entries of the two matrices are equal. For example, consider the matrix A with entries minus 1, 3, 8, 2, 7, 11, and the matrix B is given as minus 1, 4, 8, 2, 7, 11. This. Are they equivalent or are they equal? They are not equal. Why? Here. A12. This A12 for matrix A is 3, but A12 for matrix B is, which is 4. The 3 is different from 4. That means A12 is different from B12. The result matrix A is not equal with B. But the other interest here: minus 1, 8, 8, 2, 2, 7, 7, 11, and 11, they are equal. But once the interest for matrix A is, which is 3, and here another matrix for matrix B is 4, 3 is different from 4, therefore those two matrices are not equal. Another one is solve the following matrix equations for x, y, and z if they are equal. Here matrix A and two matrices are given here, and if they are equal, then what is the values of x and y and z? Now here as we have seen that in the definitions, two matrices are equal if they have the same size or order and their corresponding entries are equal. Therefore here those two matrices have the same size. The size of those matrices are what? 2 by 3. And now by using by equating the corresponding entries, we have that 1 is equals to 1, x is equals to 4. Therefore simply we obtain that values of x, which is 4, and the values of z is equals to 3, and here 2 is equals to 2. Then y minus 1 is equals to 1. Then by rearranging this, y is equals to 1 plus 1, which is 2. Then y is equals to 2, and therefore we obtain that x is equals to 4, z is equals to 3, and y is equals to 2. Therefore here, since the corresponding elements of the two matrices must be equal because of equality of two matrices, so we have x is equals to 4, that is equals to 3, y minus 1 is equals to 1, that means y is equals to 2. Now let us see operations with matrix. Let us see the operations of a matrix. Definition says that let's matrix A with entries Aij of order m by n, and the matrix B is equals to Bij of order m by n. Be two matrices of the same order, and alpha is scalar number or a constant, then what is addition, subtractions, and scalar multiple, and the negative of matrix. Now here, since matrix A is Aij and matrix B is Bij of order m by n, therefore A plus B is the same as aij plus bij of order m1. That means the matrix which is obtained by adding the corresponding entries of a and b, since they have the same size, and a minus b is the same as aij minus bij of order m1 is the matrix obtained by what? Subtracting the corresponding entries of a and b. Alpha times a is also same as alpha times aij of order m by n, which is the scalar multiple of a by alpha, where alpha is an element of real number. That means multiplications of each element or the entries of a by alpha. And the negative of a is denoted by this minus of a, which is the matrix obtained by replacing each entry in a by its negative. Note that we can add or we can subtract two matrices if and only if the order of those two matrices are the same or equal. For example, let matrix A is given here: 3, 2, 4, 2, 3, 11, 4, 5, 3, and matrix B is, which is minus 1, 4, 1, 2, 2, 1, 3, 0, 2. Then what's A plus B? Now to find A plus B matrix, A plus B here, matrix A is given here and the B is here, therefore adding their corresponding entries, since they have what? The same size or order, therefore adding this 3 plus minus 1, 2 plus 4, 4 plus 1, 2 plus 2, 3 plus 2, 11 plus 1, 4 plus 3, 3 plus 5 plus 0, 3 plus 2, which is given here. Then when we add this 3 plus minus 1 means 3 minus 1, which is 2, 2 plus 4 is 6, 4 plus 1 which is 5, and this is 6, 4, 5, 12, 7, 5, 5. Now this is the additions of those two matrices. Let us see the subtractions of these two matrices. Now, subtraction of this matrix means, which is A is given here, which is 3, 2, 4, 2, 3, 11, 4, 5, 3, and B is minus 1, 4, 1, 2, 2, 1. Okay, sorry, my just has low batteries. Now let us we continue our topics or our examples, which is A minus B. Therefore, A minus B becomes what? 3 minus 1, 2 minus 4, 4 minus 1, 2 minus 2, 3 minus 2, 11 minus 1, 4 minus 3, 5 minus 0, 3 minus 2. This is the same as, which is 4 minus 2, 3, 0, 1, 10, 1, 5, 1. Now we can add or subtract two matrices if what? If and only if they are of the same order, or they should have to have the same size. Therefore, if they are, or we say they are conformable for additions and subtraction, if what? Their size or their order are the same. Also, the order of the sum or difference of two matrices is the same as that of the two or original of a matrix. For example, matrix A is given here, which is 3, 2, 4, 2, 3, 1, 4, 1. So this matrix has size 3 by 3. Now the scalar multiple of this matrix A by 2 is also has the same 3 by 3, and we can multiply each in 3 by 2, and we obtain as 2 times A, which is the same as 6, 4, 8, 4, 6, 2, 8, 4, because multiply each, when we multiply this by 2, 3 times 2, 2 times 3, 2 times 2, 2 times 4, 2 times 2, 2 times 3, 2 times 1, 2 times 4, 2 times 1, 2 times 3, then we obtain such matrix. Now let us see properties of additions of matrices. What are the properties or the additions of a matrix? Properties for addition of matrix. So that if A, B, and C are three matrices of the same order and alpha and beta are scalars, then matrix addition is commutative, means that A plus B is equal to B plus A. And the matrix addition is associative. That means that in the bracket A plus B plus C is the same as A plus in the bracket B plus C, which is associative. Existence of additive identity. That means if 0 is 0 matrix of the same order as that of the matrix A, then A plus 0 is the same as A plus 0 is the same as A, which is the same as 0 plus A. And the 0 matrix plays the same role in matrix additions as a number of 0 does in additions of numbers. Another one is which is existence of additive inverse. That means A plus minus A the same as 0, which is the same as minus of A plus A. Property number 5 says that alpha plus beta times the whole A. If this alpha and beta are scalar, we have given here alpha and beta are scalars. So alpha plus beta the whole times A is the same as alpha A plus beta times A. And alpha into A plus B is the same as alpha times A plus alpha times B. And finally, alpha times beta times A is the same as alpha beta the whole into times. Yeah. Another one is product of a matrix and some algebraic properties of transpose of a matrix. Now, multiplication of a matrix is that while the operations of a matrix addition and scalar multiplications are fairly straightforward, but the product of A times B of a matrix and B can be defined under the conditions that the number of columns of A must be equal to the number of rows of B. If the number of columns in the matrix A equal with the number of rows in the matrix B, we say that the matrices are conformable or defined for the product A times B because of wide use of matrix multiplications in application problems. It is important that we learn it well. Therefore, we will try to learn the process in step-by-step manner. So, we first begin by finding the product of row matrix and column matrix. Let's matrix A given us with entries aik of order m by p and matrix B as bkj of order p by n. We define the product AB as A times B is equals to Cij of order m by n, where this Cij is the summation of aik bk p, where k runs from 1 up to p. This is the same as where k is 1, where k is 2, and then adding them, then we have that Cij as ai1b1j plus ai2b2j plus aipbpj, where I is equals to 1 to m and j is equals to 1 to n. Then the number of columns of A should be equal to the number of rows of B. In order to multiply the matrix A by matrix B, with order of the product A times B is m by n, and the ij entries or the elements of AB is the dot product of the ith row vector of A by the jth elements of vector B. Or simply in otherwise, we can multiply A times B if the number of columns of matrix A is the same as number of columns of matrix B. Now, the definition says that the definition refers to product A times B in that order. A is the left factor called pre-factor and the B is the right factors called post factor. That means in the product of A times B, this in that order, the matrix A is left factor, which is called pre-factor, and the matrix B, which is called that means the right factor, which is called post factor. Another, what is the properties of matrix multiplications? If A, B, and C are earning matrix, and if I is identity matrix, then the following hold. Whenever the dimension of the matrix are such that product are defined, if the product are defined, we have associative law. That means A times B times C. The bracket is the same as in the bracket A times B times C. And the multiplicative identity, that means A times I, z equals to A, z equals to I times A, where this I is identity matrix. The distributive law, that means A into B plus C is the same as A times B plus A times C. And A plus B the whole times C is the same as A times C plus B times C. Multiplications by 0, that means A times 0, z equals to 0 times A. And commutative law is not true in general in multiplication of a matrix, but addition of a matrix are commutative. So, but the product of matrix are not commutative. That means A times B is not equal with B times A. The cancellation law says that A times that means the cancellation law is not true. That means A times B is equals to 0 does not necessarily imply that A is equals to 0 or B is equals to 0, and A times B is equals to A times C does not necessarily imply that B is equals to C. For example, let matrix A is given 3 to 5 1 2 3 1 0 4 1 3 2, and the matrix B is 2 4 1 2 2 6 0 1. Then what is the product of this matrix? First, matrix A is order what? 3 by which is 4. Therefore, matrix A is 3 by 4, but matrix B is which is 4 by 2. Therefore, the column of matrix A is which is 4, and the row of matrix B is which is 4. Therefore, the product of this matrix is defined or conformable. So A times B is the same as multiplies 3 times 2 plus 2 times 1 plus 5 times 2 plus 1 times 0. This is as the first entry. The other becomes what? 3 times 4 plus 2 times 2 plus 5 times 6 plus 1 times 1. And for second row, 2 times 2 plus 3 times 1 plus 1 times 2 plus 0 times 0. And also 2 times 4 times 3 times 2 plus 1 times 6 plus 0 times 1. And finally for third row, 4 times 2 plus 1 times 1 plus 3 times 2 plus 2 times 0. 4 times 4 plus 1 times 2 plus 3 times 6 plus 2 times 1. Then we obtain as like matrix AB. The product AB is the same as 6 plus 2 plus 10 plus 1, 12 plus 4 plus 13 plus 1, 30 plus 1, 4 plus 3 plus 2 plus 0, 8 plus 6 plus 6 plus 0, 48 plus 1 plus 6 plus 0, 16 plus 2 plus 18 plus 2. And we obtain such matrix 19, 47, 9, 12, 55, 38. Now, thanks for watching my video. The persons who are not subscribed my channels, please subscribe and share.